Hello everyone, welcome to Nithin Academy and I'm Nithin. I hope you all have watched my previous video on light energy from PSLE last year. If you have not, please do because it will help you out in understanding this video more easily. Okay? So, this chapter actually has more things than the previous chapter, light from our primary school, right? So please do keep your eyes and ears open and listen to what I'm saying, okay? So let's move on to the next chapter in secondary 1 science, the chapter of ray model of light. Okay, so for the first segment of this video, I'll be going through how do we represent light. Okay, so how do we represent light? So how do we represent light? Okay, first of all, in this, what is light? Okay, so here we can see a candle, right? So light is shining off the candle. Okay, is shining from the candle because the candle actually produces light. Okay, because there's fire here, right? Okay, so light, first of all, is a form of an electromagnetic wave that carries energy. Okay, and this is a part of light is a part of the electromagnetic spectrum. Okay, electromagnetic magnetic spectrum. Okay, so I'll go through this later. So next, light actually travels at a constant speed of 3.00, basically 3 times 10 to the power of 8 meters per second in a vacuum. Okay, so constant speed. Okay, what do they mean by vacuum? So vacuum actually means like a vacuum chamber. It's not that kind of vacuum that we use to clean our houses. Okay, so this vacuum is actually like a chamber that sucks out all the air. Okay, vacuum basically sucks out air, all air. So it's basically a chamber with no air in it. Okay, so that's what they mean by a vacuum. Okay, next, light will always travel in a straight line. Okay, so light always travels in a straight line. So this is something we have already learned in primary school. Only the first two is something related to general knowledge and something that is related to secondary school. Okay, and lastly, light can be reflected or absorbed. Okay, so this is basically what is light. So let's take a look at the electromagnetic spectrum for this first point. Okay, so the light we know is actually visible light. Okay, so this is the light in every day. Okay, so if you turn on a switch at your house, right, light switch, right, so that light that we can see is actually visible light. Okay, so that's in over here. Okay, so this is the spectrum of visible light. Okay, you can see this, right? And we also have our close neighbors, the infrared radiation, ultraviolet, X-rays and gamma rays, microwaves, and radio waves. Okay, so all of these are the lights. Okay, and this is our light, visible light. Okay, the light that we can see. Okay, next. So now that we have went through what is light, now let's take a look at representing paths of light. Okay, so how do we represent paths of light? So we basically use a straight line to represent path of light, and we also use arrows. Okay, straight lines to represent paths of light, and arrows on the straight lines to represent the direction in which the light travels. So basically, if we have a straight line over here, and then I put the arrow in this direction, that means that imagine this is the light source. Okay, that means that the light is actually traveling in this direction. Okay, it's traveling in this direction. And if I do the total opposite, right, and I put the light source over here, okay, and then the arrow is going this way, that means that the light is actually traveling this direction. Okay, so I hope you understood that. So let's move on to see how do we actually represent it. So imagine there's a torchlight over here, okay? So how do we draw it? So we use a straight line and an arrow on it, okay? So a straight line plus an arrow, okay? So this is how we represent a single ray of light, okay? So now let's take a look at the next slide. So we are still going to be representing paths of light, but now it's different. We are actually representing many and different types of light beams, okay? So first, light ray. So what's the definition of light ray? Okay, so a light ray is actually a thin line, okay, of light coming from a light source, okay, while a light beam, okay, light beam, new word, light beam is basically a bundle of light rays that is called a beam of light, okay? So a light ray is basically just one single line of light, okay? It's just a line with a arrow, okay? While a light beam has many light rays, okay? So as two or more light rays together, so there's one line here, another line here, another line here. So this is basically a light beam, okay? So there's many light rays together with it. So we call that a light beam. And in this light beam itself, there are different types of light beams. So firstly being the parallel light beam, the one which is over here itself, okay? So this is the parallel light beam, okay? So this is the parallel light beam, okay? Next we have the convergent light beam. So basically from over here, it focuses down into this point, but the beams of light come down and focus into this one point, while divergent is basically the total opposite. From this point over here, actually spreads, okay, actually widens. So the beams of light actually widen, okay? So I hope you understood that, okay? So let's move on. Okay, next. So next we are going to go through luminous and non-luminous objects. Okay, so what are luminous and non-luminous objects? Okay, do not confuse yourself with luminous and non-luminous flames from the first chapter, Scientific Endeavor, okay? So these are actually meant in a different manner. So luminous meaning objects that are actually producing light, while non-luminous meaning objects which do not produce lights, okay? So please do take note. So luminous objects actually give off light on its own. So examples such as the sun lighted candle and lighted bulb. So we have the sun lighted candle and the lighted bulb, okay? Okay, and then next, non-luminous objects actually do not give off their own light, okay? Example, the moon and the books. Okay, you guys might be asking, why does the moon not give off light? Okay, so basically the moon does not actually give off its own light. It's basically the light that is reflected from the sun, okay? So here we have the moon and sun books, and there's actually many more examples. So let me just put extract, etc. and etc. okay? So I hope you understood that. So these are just examples of luminous and non-luminous objects and what it actually means, okay? So I hope you understood that. Now let's move on, okay? Okay, so what is reflection? So this is segment number 2. So what is reflection and what are its applications? So let's take a look at this, okay? So what is reflection, first of all? Okay, so how do we see things? Okay, how do we see things? We are able to see objects when light travels into our eyes, okay? So this is something that we need to know, and this is something that we have already learned in primary school. So we are able to see things when light travels into our eyes, okay? So what is reflection? It's basically reflection is the bouncing of light rays off a surface, okay? So imagine if I have this pen over here, okay? So this pen, so the light actually comes and bounces off this pen into my eye so that I can see this pen, okay? So this is what a reflection actually means, okay? Next, so here here we have basically this plane is actually a plane of mirror. Okay, it's a plane mirror. So this is a mirror. Okay, so this is a light ray which is shot in this direction. Okay, and it shot down and it reflected and it went back up. Okay, so basically incident ray. So what's an incident ray? So incident ray is basically the ray of OA. Okay, OA. So OA is basically this ray over here. So this is actually a incident ray. Okay, so how do we say so? The ray of light that strikes the surface. So from A, it strikes at a surface at O. So this is actually the incident ray. Okay, so let me just label that. So this is the incident ray. Okay, then next, the angle of incidence, the reflected ray. Next is the reflected ray. Okay, is basically O and B. So this is the light ray that actually bounced off the surface, which actually reflected by the surface. Okay, so the ray OB is actually the reflected ray. So let me label that the reflected ray. Okay, so reflected ray. Okay, so this is the reflected ray. Okay, next off we have the angle of incidence. So it basically means the angle that the incident ray makes with respect to the normal. Okay, so what the normal is basically a perpendicular line coming down onto the mirror surface. Okay, so as you can see, this over here is actually the normal. Okay, so it's basically a perpendicular line. Okay, so the angle of incidence is basically the incident ray makes with the respect to the normal. So over here, so this is actually the incident ray represented by the letter I. Okay, and then next we have, just like the angle of incidence, the angle of reflection are represented by the letter R. Okay, so the angle of reflection, so it's basically the angle that the reflected ray makes with respect to the normal again. Okay, so I hope you understood that. And then next we have the normal, ON. Okay, so what the normal is basically an imaginary line that is perpendicular. Okay, it's basically perpendicular to the surface of contact. It is represented by a dotted line. Okay, so we use dotted line, okay, to draw it. Okay, so I hope you understood about reflection. Now let's move on. Okay, so here we have the law of reflection. Okay, so let's take a look at the law of reflection. Okay, so here we have a light bulb. Okay, so the law of reflection states that during reflection, the angle of incidence I is equal to the angle of reflection. Okay, so in the previous image, you could have actually seen that I was actually equal to R in the previous slide, the image, right? You have seen it, right? So it was actually equal. Okay, so basically so imagine this is the mirror. When an angle of incidence is, this is the normal, right? Sorry. Okay, so basically I is equal to R. So imagine that this is the plane mirror. Okay, and then the incident ray comes in, and then the reflected ray comes in, and then here is the normal. Okay, so this I is actually equal to this R. Okay, so that is what they're actually trying to tell us. Okay, so basically over here, so this is what I'm trying to say. So the incident ray over here is actually 60 degrees, right? Okay, I mean the angle of incidence is actually 60 degrees, right? And the angle of reflection, the reflected ray, so basically the angle of reflection is also 60 degrees. So this is what they meant by I is equal to R. Okay, so I hope you understood this. Okay, so this is the incident ray coming in and striking on this surface and reflecting off. Okay, so the angle of incidence is actually 60 degrees. Okay, and the angle of reflection is also 60 degrees. So this is like a formula. Okay, so whenever they ask find the angle of reflection, if they give you the angle of, if they gave you this angle, right, if they gave you this angle without these two angles, okay, and they ask us to find R equals mystery. Okay, so what we are supposed to calculate, right, is basically take, so you know that this is a 90-degree angle, right? So we take 90 degrees. So what we will actually do is take 90 degrees minus 30 degrees is equal to what? Is equal to 60 degrees, right? So 60 degrees. So angle of incidence is equal to 60 degrees, which is equal to angle of reflection, which is also equal to 60 degrees. And what if they ask for the total then? Okay, if they ask for the total angle, right, you should just take 60 plus 60. Okay, so we know that it is 120 degrees. Okay, so I hope you understood that. So let's move on. Okay, next we have the characteristics of a plane mirror image. Okay, so here we can see that there is this adorable child over here sleeping beside a mirror. Okay, so he's laying down beside a mirror, and we can see that his mirror image is formed. So what are the characteristics? First of all, we have the image distance is equidistant from the object distance. Okay, so it's basically equal distance. Okay, so the image distance is equal. Okay, if you don't understand the word equidistance, basically, so it comes from the word equal. Okay, so the image distance is equidistant from the object's distance. So we can see that his head is the same amount, right? Okay, we can see that his elbow is also the same amount, right? Also see that the fish is also the same amount, right? Okay, so all of these are actually equidistant. We can see that the fish head is also the same amount. Okay, so all of these are equidistant, making the image equidistant from from the actual object. Okay, in this case it's actually a baby. Okay, so this is what they mean by equidistant. Next, number 2, the image size is similar to the object size. Okay, the image size is similar, right? So we can see this baby over here, right? So this is the baby size. Okay, so you can see that the baby size, right? And here it should be similar. Okay, we can't see the rest of the hand. Okay, so as you can see, right, the baby size is actually really similar, the one that I've outlined in blue. So we can tick this as well. So this is correct and this is also correct. Okay, and number 3, the image formed is actually upright and laterally inverted. Okay, so this image is actually upright, but it's also laterally inverted. So how do we tell it is laterally inverted? We actually take a look at this fish over here. You see this fish? Yeah, we take a look at that fish. So that fish is actually facing this direction, right? And over here, it's actually facing this direction over here, right? But in the mirror, it's actually facing the opposite direction. So this tells us that it is actually laterally inverted. Okay, so right becomes left and vice versa, and left becomes right. Okay, so this is also proved to be correct. Next, the image form is virtual. So this image is actually not real. Okay, so we can't actually feel it, we can't actually touch it. Okay, it's not real. So this too also has been proven to be true. Okay, so these are the characteristics of a plane mirror image. So what is a plane mirror actually? Plane mirror is basically a normal mirror. Okay, normal mirror. Okay, so I hope you understood that. Now let's move on. Okay, so next, so to locate the image formed by a plane mirror. Okay, so this is basically for like drawing the actual image in a plane mirror and reflect and showing the rays that are to the eye. Okay, so this is the 4 steps of approach. First step, okay, first step, identify the location of the object. Okay, so we are supposed to identify. Okay, then we are supposed to locate the position of the image. Okay, locate the position. So basically, how do we do that? The object distance and the image distance is equivalent, and we also draw the equidistant line, image positioning using dotted lines. Okay, so this is how we do it. So this is step 1 complete. Okay, so this is step 1 complete. Okay, next. So step 2, basically what we are going to do is to draw 2 diverging rays. Okay, draw 2 diverging rays from the image to the eye. Okay, this is step 2. So virtual rays in the mirror is actually should be dotted, while real rays should be solid outside the mirror. Okay, basically in front of the mirror. Okay, okay, so I hope you understood that, and step 2 is complete. Okay, so step 3, draw 2 rays from the object. Okay, draw 2 rays from the object reflecting surface. Real rays, okay, the real rays should be solid by the law of refraction. Draw incident rays from the object. Okay, so the incident rays should be from the object itself, not from the image. Okay, so with that, step 3 is complete as well. Lastly, step 4. So last step, we are supposed to draw arrows to indicate light reflecting from the source into the eye. Okay, so with that, step 4 is also done. So let's just take a quick recap. Step 1, identify and locate the object. Okay, then we are supposed to locate the position of the image, and how we are supposed to do it. The object's distance and the image distance is actually equal, and we are supposed to draw the equidistant line plus the image positioning using dotted lines. Okay, so next we are supposed to draw 2 diverging rays from the image to the eye. Okay, virtual rays in the mirror should be dotted. Okay, so it's supposed to be dotted, while the real rays should be solid. Okay, not dotted, it should be solid, so basically outside the mirror. And then for step 3, we have to draw 2 rays from the object to the reflecting surface. Okay, the real rays should be solid by the law of refraction. Draw the incident rays from the actual object and not the image. Okay, step 4, draw arrows to indicate the light reflecting from source into the eye. Okay, so these are the 4 steps we need to take note. So please keep this in your mind, and we are going to take a look at the next slide. Okay, so ray diagram. So we are taking a look at a ray diagram right now. So this is a ray diagram already drawn for us. So this is the object, this is the image, and this is the eye. Okay, so the image in the exams, right, they actually ask us to draw the image and the rays. So the image is actually not drawn for us, and the rays are actually not drawn for us, and this dotted equidistant line is not drawn for us in the exams. Okay, so in the exams, what there will only be, right, is the things that I'm outlining in blue. Okay, so this will be there, and the eye will be there. Okay, and this plane mirror will be there. Okay, Okay, these are the only things that they will provide for us in the exams. The rest all we are supposed to draw it on ourselves. Okay, I think it's a bit hard for you guys to visualize using the blue line, so let me just highlight what will be provided. So the eye, and then this. Okay, so that's it. Only these three. Okay, only these three will be provided, and we are supposed to draw the image and the rays by ourselves. Okay, and also the equidistant line. Okay, so let's take a look at the step-by-step process of what we actually do to draw. Okay, so first step, what's the first step? Do you guys remember? So we are supposed to identify and locate the object. So how do we do that? We actually use our something called the ruler. Okay, so when you always go into examination halls, bring this thing called the ruler. Okay, so we use this to actually measure. Okay, so we measure the distance. Okay, so from this ball to this ball, from this ball to the plane mirror is actually about 5 cm, and then it's supposed to be 5 cm on the other side as well. So from this plane mirror to this ball is 5 cm as well. Okay, so like that. So let me just give you an example. From this point over here to this point is actually 5 cm. Okay, and from this point over here to this point over here is actually 5 cm. And in the exams, you might be asking, how do we actually draw a circle? So this exact same question actually came up for my end of year exams for my school. Okay, so what did I actually do to draw this circle over here? So it is compulsory to draw the image, and when you're drawing the image, right, it's supposed to be in dotted lines. Okay, so what did I do? So I actually took 4 points. Okay, so I took this point, I took this point, I took this point, I took this point, and I took the center point. Okay, so actually also bring a compass along with you. Okay, for your exam. So what I did was I actually didn't use a compass for this question, but most of my friends did use a compass for this question. Okay, so what did I do is actually to measure this point to this point over here, and this point to this point over here, and this point to this point, and this point to this point. Okay, so this is what I did. So basically all these points should be equal. Okay, so this point to this point is equal, this point to this point is equal, this point to this point is equal, and this point to this point is equal. Okay, so I've already drawn all the equidistant lines. Okay, so all of these are equidistant. And then what I did, so let me erase the lines because it's a bit messy. Okay, and then what I did is to actually connect the dots. Okay, so there's one center point here, one here, one here, and one here, and one here. So what I did was to actually use my hand and to connect the dots as a circle. Okay, it wasn't the perfect circle, but the teacher actually accepted it. So as long as we get the understanding over there, okay, it doesn't need to be a perfect circle, but it always needs to be closed. Okay, you can't just leave it as dot 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 and then the dot goes here. Okay, if you do that, then it will be wrong. Okay, so this is what I did for my exam basically. So you need to think from another point of view when you're doing your exams in this type of area. Okay, so please do take note of that. So now that we have actually identified the location of the object, we have actually drawn the image itself. Now what we are going to do is to actually draw two diverging rays from the image to the eye. Okay, so these are the two diverging rays which are drawn from the image to the eyes. So this pink one and this blue one. So what they have done over here is to actually put the dotted lines from the side of the image, right? But when they passed the image, they actually went to a solid line. Okay, over here you can see it's actually a solid line instead of a dotted line. Okay, so that is one of the rules, because in the inside the image inside the mirror, right, the rays are actually not real. Even the image itself is dotted because the image is actually not real, it's actually just a virtual thing. So all of this is not real. Okay, so that is why we use dotted lines to represent that. Okay, and then so since this line goes into the eye, right, the next step we need to do is to actually third step, right, we draw two rays from the object reflecting the surface. Okay, so these are the two rays, 1 and 2. These are the two rays reflecting the surface and into the eye. Okay, so it's reflecting the surface and is connected to the same dots over here. It's connected to the same line over here. Okay, as you can see. So this is how we are actually supposed to draw it. And lastly, we are supposed to draw the arrows to indicate where the light is reflecting. So these are the arrows we are going to draw lastly. So 1, 2, 3, 4. Okay, so the 4 arrows. And with that, we are done with this this part. We get 3 marks for this. Okay, 3 marks. So what are the 3 marks they are giving us for? 1 for the image, 1 for this line. Okay, one for one of this set of lines and another for the other set of lines. Okay, so please do take note of that. And they don't really mark for the equidistant line, but this is like a working. Okay, so we need to show that. Okay, so I hope you understood this. Now let's move on. Next. Okay, next we are going to take a look at concave and convex mirrors. So I've already went through plane mirrors, right? So plane mirrors, they are the normal mirrors, and convex and concave mirrors are actually like special mirrors. Okay, so let's take a look at them. So types of mirrors, so concave and convex. So the characteristics of a concave mirror is actually that the surface bends inwards, the surface of the mirror. So they actually use this for like a dentist mirror. You know, when you go to the dentist, they actually want to see your tooth, right? They actually use this concave mirror. They focus reflected light to a single point, these mirrors. Okay, and they can also reflect light rays from a point source into a parallel light beam. Okay, and the image form is actually virtual and magnified, so the image seems bigger. Okay, and the purpose is for car headlights. Okay, car headlights, dentist mirror, and solar heater. Okay, and then next we have convex mirrors. So convex mirrors are basically the total opposite of concave mirrors. So their surface bends outwards. They are also known for diverging mirrors. They cover a wider field of vision instead of just focusing to a single point, and they are upright, disordered instead of they are disordered. Okay, so it's a bit harder to see, and they are diminished, basically meaning they're smaller. Instead of magnified, they are like smaller. So this is for security mirrors, cars side rear view mirror. Okay, side and rear view mirror. So the side and rear view mirror, you can see that everything is in a wider field of vision, right? So that you can see the whole road just from looking in front. Okay, so I hope you understood that. So this was concave and convex mirrors. Okay, next let's take a look at the types of reflection. Okay, so there's regular reflection and there's diffuse reflection. Okay, so let's take a look. So regular is actually like they are parallel to each other. Okay, so this is parallel, and these are parallel. Okay, so this is regular, while diffuse, which is irregular, is basically on a rough surface. Okay, and this is on a straight surface. This is on a rough surface, so it goes all types of ways, all types of angles. Okay, while regular is always on a one constant angle, so all these angles are actually equal, while all these angles are all different. Okay, so I hope you understood that. So let's take a look at what it actually means. So regular is actually the image formed is clear and undistorted. Okay, it's clear and undistorted, and the smooth surfaces like a mirror. So types of surfaces, smooth surfaces like a mirror. Okay, while for diffuse, the image form is actually there is no image form, because it is the surface is so rough that the image is so distorted that you can't actually see an image, so that there's actually no image formed. Okay, so this is basically reflection on a smooth surface. Okay, so we can see the mountain clearly, we can see all these trees clearly. Okay, so this is basically the mountain's reflection on a smooth surface of water, and this is a mountain's image on a wavy surface of water, so basically rough surface. Okay, so this rough surface over here, we actually can't see, we can't make out where's the image itself. We can see the outline, but we can't really see the image itself. Okay, we can't see like the details. We could see the colors we could see over here, right? Okay, over here there's actually nothing. Okay, so this is what they mean by regular and diffuse, the types of reflection. Okay, so I hope you understood that. Now let's move on. Okay, for the third segment of this video, I'll be going through what happens when light passes through different types of mediums. Okay, so what happens when light passes through different mediums. Okay, so refraction. So this is basically called refraction. Okay, so refraction of light. So it actually appears like this. So the pencil, right, it's supposed to appear straight, right? Instead, it looks like the pencil is actually cut in half and they put another one here. Okay, so refraction. What is refraction? Okay, what is refraction? So refraction is the bending of light when it passes through from one medium to another with different optical density. So light actually passes from air to water, and air and water actually have different optical densities. Okay, so that is why this image appears as such. Okay, so I hope you understood that. Next, why does refraction occur? Okay, refraction occurs because the speed of light is different in different mediums. Okay, so the speed of light in air is different from the speed of light in water. Okay, and when light travels from a medium to another with different optical density, basically the refractive index n over here, so this is the refractive index n, it will actually bend. So you can see for air the index of refraction is this, while for water is actually larger than air, right? So that's why this image appears as such. Okay, so let's go through more in depth in this. Okay, next. So what is the direction of bending? So what determines where the direction of bending will happen? So let's take a look. So here is air and here is water. Okay, so from air to water, this is the light ray coming in. Okay, this is the incident ray. Okay, incident ray. Okay, it comes in and it comes to water. So what happens? So it's actually traveling from a optically less dense to an optically denser medium. Okay, it's actually light is actually traveling from an optically less dense to an optically denser medium. So what happens is that the speed of light decreases. Okay, the speed of light decreases. Okay, so always remember, less dense to denser is always that the speed of light decreases. So what happens when the speed of light decreases? Okay, so when light travels from an optically less dense medium to an optically denser medium, it bends towards the normal. Okay, the speed of light decreases and it bends towards the normal. So we can see that the normal is over here, right? So this is the normal, right? And the light ray will actually bend towards the normal instead of going straight through it. Okay, so you can see through the image over here, right? Instead of just going as one straight line, it actually bends towards the normal because of the speed of light decreasing. Okay, next. Okay, next scenario we have here. So what is the direction of bending? So it's traveling from water to air. Okay, so water, we can already know that it's a denser medium, right? Denser, less dense. Okay, so what happens when light travels from a denser medium to a less dense medium? Basically the total opposite. The speed of light increases. Okay, and it will actually travel away from the normal. Okay, the total opposite. Okay, so instead of traveling towards the normal like this, it actually travels away from the normal. Okay, so I hope you understood that. So this is when light from an optically denser medium travels to an optically less dense medium. When the speed of light increases, it actually bends away from the normal. So the normal is here, it actually bends away from it. Okay, so I hope you understood that. Now let's take a look at the next scenario. Okay, the next scenario over here. So the ray of light actually went straight down, and you see that the water and air, right? Water is actually a less dense, right? Denser, right? Denser, right? And air is actually less dense, right? Less dense in optical density, right? So why didn't the ray of light bend or go away from the normal? Okay, you have to know something. So bending of light only happens, refraction of light only happens when the light comes in at an angle. But if it comes totally perpendicular, right? Totally perpendicular, right? It means that it will stay perpendicular and go straight. Okay, the ray of light will not like go towards or away from the normal. Okay, so you have to understand that. So this the thing. So the third scenario, perpendicular to the boundary. So what happens is the speed of light remains unchanged and the light does not bend. Okay, so this is a special scenario. Okay, so I hope you understood that. Now let's move on. Okay, refraction of light through a glass block. Okay, this is something that you should know. Okay, so here is a glass block. Okay, so we can draw two normals here, basically where the incident ray hits, where the incident ray hits. Okay, so two normals. Okay, so incident ray hits over here. Okay, strikes at this point over here, and then it actually goes down over here and it hits this point and it goes back to where it actually started. So what is this phenomenon? So you can see that these two things are actually like parallel to each other, right? So this is parallel to this and this is parallel to this. So you can see that both of them are actually parallel, right? So what is this thing? So it's basically when the incident ray strikes at this angle, right? And it enters from air to a glass block which is actually denser. So it bends towards the normal. So from an optically less dense medium to an optically denser medium, the speed of light increases, decreases, and it bends towards the normal. And then when it comes out of the glass, right, from a denser medium to a less dense medium, right, optically less dense, right, the speed of light actually increases and it bends away from the normal, and thus it actually forms a parallel line over here. It actually goes back to the exact same angle where it started to come in at, because both of these are actually air, right? They are the same optical density, that's why. Okay, so here glass is an optically denser medium than air, so this I already told. Okay, and next, the light ray enters at an angle. When the light ray enters the glass block, the light ray bends towards the normal. When the light ray exits the glass block, the light ray bends away from the normal. So this is basically what I just said. Okay, next. Okay, still through a glass block, what happens is that, so we need to take note of some key points. Always identify and differentiate optical densities of mediums. Okay, and always draw the normal. Okay, always draw the normal. This will always help you out in visualizing. And determine if the reflected ray, a refracted ray, will bend towards or away from the normal. Okay, so you need to determine. And lastly, the emergent ray should be parallel to the incident ray. So this is the emergent ray, right? And this emergent ray should be parallel to the incident ray, like I just draw that line, right? So let me draw it again. So it is actually parallel to the incident ray. Okay, so we can see that it is parallel. Okay, okay, so we can see that. So it should always be parallel to the incident ray. So let's go to the next slide. Okay, so next the dispersion of light. So this is something that is not oftenly tested, but it's something good to know. Okay, so white light can actually separate into 7 constituent colors by the process of refraction. So white light, and this is a glass prism. Okay, so these are basically the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Okay, so white light actually consists of all these colors. Okay, so white light comprises of 7 colors: a red, orange, yellow, green, blue, indigo, and violet. And red light will bend the least, while violet will bend the most upon refraction. So different colors of light actually bends differently because of their color. Okay, so red light bends the least, while violet actually bends the most. Okay, so this is the dispersion of light. So I hope you understood that. So why did I show you that? Because this is actually directly linked to rainbows. Okay, rainbows. So dispersion of light. So this is one of the rainbows in Singapore that we have seen. Okay, this was one of the largest rainbows. Okay, and this rainbow, how did it actually form? So light bends when it travels from air to water due to the decrease in speed. So rainbows actually form when it is sunny and rainy at the exact same time. Okay, so water due to the decrease in speed. After raindrops are still present in the air, as the sunlight crosses the boundary between air and water to enter each raindrop, each colors of the light slows down to different extent, hence bend by different angles, dispersing light into 7 colors. So what they actually mean, right, is that the raindrop acts like a glass prism. Okay, acts like a glass prism. Okay, and the sun gives off white light. Okay, so this is the thing. Okay, so I hope you understood that. Okay, next we have the dispersion of light again. So white light, so this is how the raindrop acts like a prism. Okay, so it goes in, it bounces off this, it refracts. Okay, so this is how it basically disperses. Okay, and this is not that important, it's just good for you to know. Okay, so let's move on. Okay, next, the last segment of this video. So what is the impact of application of the radiation on the society and the environment? Okay, so what is the impact of application of radiation on the society and the environment? Okay, so first off, let's take a look at infrared radiation. So this is something that is in our electromagnetic spectrum as well. Electromagnetic spectrum. Okay, so infrared radiation. So this will be the first out of the 3 that we are going to take a look at today. And this is basically infrared radiation. So this is something helpful to us. So it actually helps us to take temperature of the people during the COVID times. Okay, next, application. What is the application? So the application, first of all, is thermal imaging cameras such as this. So actually shows us whether people the temperature of their people. Okay, so it is found in airports, public buildings, and offices to screen people for fever. Okay, and camera detect infrared radiation emitted by a person, forming an image that indicates body temperature. Okay, next, so that was the application. Okay, and this is going to be the harmful effects. Okay, so we just took a look at the applications. Now let's take a look at the harmful effects. So overexposure to infrared radiation causes harm to our body. Okay, so let's take a look. Workers who have prolonged exposure to IR should wear goggles and protect their eyes. Okay, So if not, they will have this causes it causes harm to their body, right? So in order to prevent that, they actually wear goggles and protect their eyes. Okay, so infrared radiation also is also trapped in the atmosphere, results in climate change. So the infrared radiation trapped in the atmosphere results in climate change. So you can see this half of the city is like in drought. It's like in drought, bad weather. While this side is like paradise, right? So this is what we mean by climate change. Okay, so this is what we mean by climate change. Okay, so I hope you understood that. Okay, next, the temperature on the earth increased and the weather pattern changes. So this is basically climate change. Okay, so this is climate change. Climate change. Okay, so let's move on. Okay, secondly, we have ultraviolet radiation. So this is the second thing that I'm covering over here. Okay, ultraviolet radiation, basically UV radiation. Okay, so this too is a part of our electromagnetic spectrum. Okay, next. So this shows about ultraviolet radiation to sterilize equipments of the medical. Okay, so this is one of the applications. So actually UV light sterilization, it actually disinfects our medical equipment, food and water without using chemicals. Okay, so this is the application, the good thing of it. Okay, but UV radiation, also small amounts of exposure to increases vitamin D. Okay, so small amounts of exposure to UV radiation actually increases vitamin D production. Okay, so just like if we stand in the sun, now we get vitamin D, right? So sun actually is like a form of a UV radiation as well. Okay, so I hope you understood that. Next, so we treat babies with certain medical conditions with UV radiation. Okay, so I hope you understood that. Okay, next off in UV radiation we have harmful effects. Okay, harmful effects. So here there is this image of the UV radiation going into the dermis. Okay, and this actually damages our skin. So overexposure causes harm to our eyes and may cause skin cancer. So this is something very, very bad. So this is bad. Okay, so I hope you understood that. Okay, now that we are done with the harmful effects and application of UV radiation, let's move on to the third thing, visible light. Okay, visible light. So this too is in the electromagnetic spectrum. Electromagnetic spectrum. Okay, so this is also in the electromagnetic spectrum, and it is the last one, the third one. Okay, next. So this is like a plant getting light. Okay, so visible light, and this is the city giving out light. Okay, all the lights of the buildings, which actually helps us to see things. Okay, so application, allow plants to carry out photosynthesis, allow us to carry out daily activities. Okay, that's it. So daily activities such as to see things, basically without seeing anything we can't do anything. Okay, imagine if the world was actually full blank and we couldn't see anything, what could we possibly achieve, right? Okay, so that's how maybe blind people feel like. Okay, so that was the application of visible light. So what is the harmful effects? So these harmful effects are actually not related to us. Okay, so actually does relate to us as well. So cause in chemical changes to some materials deteriorating the quality. Okay, so this light actually causes chemical changes to some materials deteriorating the quality. Okay, so this is one of the harmful effects. Secondly, light pollution negatively affect living things in carrying out their sustainable activities: migration, sleeping, escaping from predators. Okay, so their sleep cycle will be ruined, their migration will be ruined, they will not know which is day and which is light, and they can't escape from predators because uh, and they might be able to escape from predators basically, because some predators are born to like see if in the night, right, with like night vision and stuff. So like the owl for perhaps has night vision to catch a prey. Okay, and imagine with light pollution, right, the rat can actually escape while the owl will not have any food to eat. Okay, and so the whole food chain will be broken. Okay, next, it also uses up a lot of electricity. Okay, it also uses up a lot of electricity, so this actually wastes electricity in light. Okay, so with that, I've come to the end of this video. Thank you for watching, everyone. I hope you have enjoyed this video and understood more about secondary 1 science, the fixed topic of ray model of light, and I hope this video really helps you. And if you're not subscribed to Nithin Academy, please do subscribe and be a part of our family. Thank you and bye bye. I'll see you again in our next video. Bye.